Oh, hello guys. Today we're gonna learn about probability measures. So, what is probability measure is all about? A probability measure is a real valued function defined on a set of events in a probability space. So, when I mention a real value function, it means that the values are numbers. And why do we have to learn about this probability measure? In fact, by using the concept of probability measure, we can measure the uncertainty, for example, in the financial market. In the financial market, the probability measure will be used to determine the expected value of the future payoff for current value of assets. And the likelihood of an event is usually measured by a number between 0 and 1. Okay, so now let us go to the definition of the probability measure. Let omega and the sigma algebra be a probability measure, be a, be a measurable space. Then a probability measure on A is a mapping from A to the number 0, 1. So recall that the 0, 1 here refers to the probability values where the probability must be between 0 and 1, and it must satisfy the following three conditions. So the first condition says that the probability the probability of the probability of omega is equals to 1. We can write this as probability of a sample space is 1. Sample space. Sometimes people call the sample space as uh, also in mathematics we call it as a full set. Okay, secondly, for any sequence Bn of disjoint events in the sigma algebra A, the probability of the union of the events is actually equals to the summation of the probability for each event. So maybe I can write down here the probability of the union of all events Bi is equal to the summation of the probability for each event. Okay, and the third definition says that the triple omega AP is called as the probability space. So the event omega is called the sure event. It's surely to happen, and the empty set is impossible events or nothing happen. All right, so and then from this definition, we consequently has the following properties. If we consider an event B and its complement BC, therefore the probability of the event B plus with the probability of the complement of the event is actually the probability of the sample space, which is equals to 1. Or we can also write like this, yeah, in another way. Uh, All right, and then next we're gonna see some properties for the probability measure. Okay, so what's been mentioned here? What's the properties? So there are 5 properties. Maybe I can mention some of the properties. Okay, so the first property says that here is probability of empty set is 0, or yeah, so it means that no events. Okay, no event is equals to the empty set. Okay, so the second one, it says that for all events B1, B2 in the sigma algebra A times sigma algebra A, the if you have that the first event, the B1, the event B1 is smaller than the event B2, then therefore the probability of the smaller events is less than the probability of the bigger event. So maybe I can write down here the probability of smaller event is less than uh, the probability of larger event. Okay, and then we have more properties saying about increasing sequence and then decreasing sequence, and then the okay, so properties number 5 is as mentioned just now, and then I believe that you guys can read the proof by yourself. Um, okay, all right. Okay, so the next one we go to example 13 and 14 about the examples on probability measure. Okay, example 13 shows actually explain about the uniform probability measure. So why do we call it as a uniform? Um, this is because we put or we give the same value of probability for each event. So same weight. So we have so we actually give the same weight or probability to each event. So for example here, if we have let the cardinality of omega equals to n, so cardinality here means cardinality. Cardinality here means um, number of, sorry, um, okay, so sometimes cardinality can be said as number of elements, or sometimes number of length. So how many length? Yeah, we can also, and we have the number of elements of omega is n, and then we have the sigma algebra as the power set of omega, and then suppose that in one event, uh, in one experiment, so we have n number of event. So we give since we give the same probability, therefore we have 1 over n. So for example, is you Sorry. So for example, if we throw a die, then you might have six outcomes, and suppose that if I give the same probability for each outcome, then therefore I will get so the probability will be 1 over 6. So means that probability is 1 over 6 to get number 1, probability 1 over 6 to get number 2, and so on until number 6. Okay, and if we go to the example 14, so this is about uh, probability measure with area, and in fact actually we use the concept of Lebesgue measure here. Okay, all right. So in this example 14, so our omega is the unit square of 0, 1 to 0, 1. So it's like this. So our omega is from 0, 1 to 0, 1. So this is our omega. And so it says here that it has to be equipped with a Borel sigma algebra. So meaning that it contains all the open sets, and yeah, actually you guys can yeah, split this into some open sets. Okay, all right. So what it tells you here is about the, yeah, probability measure on the unit square. Actually, if we mention about the Lebesgue measure, so if you see here, if you consider one-dimensional Lebesgue measure, actually you consider length. So, for example, length from A to B is B minus A, isn't it? So if you consider two-dimensional Lebesgue measure, actually you consider an area. So an area with A, B, and C, D. So the measure will be B minus A times D minus C. And in fact, if you consider like more higher dimension like 3D, then actually you compute a volume. So I think that's all for now. Thank you very much.